Hi there, and welcome to Tech with Shaping Pixel. In this video, we are diving into part 11 of the Google Associate Data Practitioner full crash course, where we will explore database migration strategies for GCP.
Migrating a production database to Google Cloud can seem overwhelming, but breaking it down into clear steps makes the process manageable. Let's explore the essential phases and best practices for a smooth migration. Start with the assess phase. Document every component of your current system, including all applications, servers, and resources. Identify both dependents, which rely on your database, and dependencies, which your database relies on. List out performance requirements, current costs, and any special needs like encryption or compliance. Understanding your system structure and requirements is crucial before making any changes. Next, select the right database technology for Google Cloud. Consider features, scalability, maintenance, and pricing. If multiple options fit, prototype with sample data to test your use cases. Remember, copying a MySQL instance differs from migrating Postgres to Cloud Spanner, so choose carefully. For smaller or less dynamic databases, a simple export and import may work. For larger or constantly updated databases, use tools like Database Migration Service or Cloud Storage. If your data is massive, Google Transfer Appliance can help speed up the process. Document everything, share with your team, and choose tools that fit your needs. With careful planning, Google Cloud offers solutions for every migration scenario.
The second phase of database migration is all about planning. Start by mapping out your final solution in detail, including every step and the end state. Use your list of dependencies to determine what needs to change and in what order. Building prototypes or proof of concepts can be invaluable. If you are unsure where to begin, try migrating a test database and document each step. This helps you compare options and estimate realistic timelines and costs for your migration. Decide whether you need a one-time migration or a continuous migration. One-time migrations are simpler and involve taking the database offline, while continuous migrations keep the database online and synchronize data over time, minimizing downtime. For one-time migrations, consider breaking the process into stages or using incremental backups to reduce downtime. Continuous migrations are best for large, frequently updated databases or when downtime is not an option. Every migration plan needs a clear methodology and a fallback plan. Prepare for failures by planning how to revert changes if needed. Automate as much as possible to reduce risk and ensure both migration and rollback steps are reliable. The third migration phase is all about deployment. This is where you set up your infrastructure, provision your database, and move your data. It is the moment when your planning turns into real, working systems. Automation can make this process smoother. Google Cloud offers tools like the Google Cloud Software Development Kit, or SDK, for custom scripts, and you can use Terraform or Kubernetes templates to provision resources. Schema conversion is often tricky, so tools like Dataflow, Cloud Data Fusion, and Cloud Composer can help reduce risk. A typical migration involves copying your records, testing everything, migrating client connections, and then retiring your old database. If you are doing a live migration, you will need to drain client connections by pausing updates and letting the new database catch up. Always take a backup before switching clients to the new environment. After migration, thorough testing is crucial. Unit, integration, and regression tests ensure everything works. Use cloud logging and monitoring to track performance and set alerts for issues like CPU usage exceeding 75%. Having enough resources and people on hand is vital for handling last-minute issues. If you planned well in earlier phases, this step should be smooth execution. After completing your migration, the next crucial step is optimization. Start by gaining a clear understanding of your system's health. Track how often error messages occur, what types they are, and the speed of your queries. Effective diagnostics are essential, so build tools that make troubleshooting quick and easy. It is not enough to simply collect logs. You need a powerful way to search through them. Use Cloud Logging and Logs Explorer to stay on top of issues. Go beyond reacting to problems by setting up cloud monitoring to send alerts for spikes in demand or slow queries. Once you can measure and monitor everything, look for improvement opportunities. This might mean rewriting queries, generating missing indexes, or converting transactions to minimized locking. If you have a large monolithic database serving multiple microservices, consider breaking it up for easier maintenance and better data storage formats. Review your options for availability and scalability. Google Cloud helps you handle spikes in demand and outages. Small changes can lower your monthly bill. Switching to Google Managed Services can reduce administrative and licensing costs while improving scalability. Managed instances integrate seamlessly with Google's ecosystem, making advanced analytics and machine learning more accessible for your data. Let's quickly review the 4 essential phases of database migration so you can approach your next project with confidence and clarity. The first phase is assess. Here you identify all dependents and dependencies. That means everything that relies on your database and everything your database relies on. Once you have a clear picture, you can select your target database and choose the right tools and automation to support your migration. Next is the plan phase. In this stage, you decide on your migration methodology and write out every required step. It's also crucial to develop a fallback plan. Start by asking yourself if this migration will be a one-time event or a continuous process, as this will shape your approach. Now, it's time to deploy. This is where you put your plans into action by creating your new database instance, replicating records, and migrating client connections. Careful execution here ensures a smooth transition. Finally, optimize. Make sure logging and monitoring are set up to catch issues early. Look for ways to boost performance, resilience, and cost efficiency. Thanks for watching, and don't forget to rate the course. Setting up a production database on Google Cloud Platform is just the beginning. The real challenge is keeping it healthy over time. That is where monitoring and quick issue detection come in. Google Cloud offers a tool called Cloud Monitoring. Cloud Monitoring lets you track your cloud resources performance using dashboards and alerts. This way, you can spot problems before they impact your database. After logging into the Google Web Console and searching for monitoring, you will find dashboards. These dashboards display charts and graphs showing metrics like queries, page reads, network connections, and CPU utilization for your Cloud SQL database. While Google provides default dashboards, you can create your own. Simply click Create Dashboard, then drag and drop charts for the metrics you care about, such as CPU utilization or connection counts. Customize them to fit your needs and save your dashboard for future use. Instead of watching dashboards all day, set up alert policies. Choose a metric like CPU utilization, set a threshold, and pick how you want to be notified: email, SMS, Slack, or more. Monitoring and alerting are built in for all Google Managed Services like Cloud SQL and Firestore. But what if you are running an unmanaged service, such as MySQL on a compute engine virtual machine? In that case, you can install the Ops Agent. The Ops Agent collects telemetry data from your virtual machines and sends it to Cloud Monitoring. The easiest way to install it is through the web console. Just click Set up Agents, select your virtual machines, and hit Install or Update Agents. Google handles the rest, and soon your metrics will appear in cloud monitoring. Prefer manual installation? You can copy the provided commands for Linux or Windows and run them in your terminal or include them in a custom startup script. This flexibility lets you monitor any database, even if it is not managed by Google. But what should you monitor? Focus on service level indicators, or SLIs, which measure your service's performance. Set service level objectives, or SLOs, as internal goals and service level agreements, or SLAs, as customer commitments. Identify your key metrics, set up dashboards, and create alert policies to stay informed and maintain reliable service.
When a database problem strikes, finding the root cause quickly is crucial. That is where log files come in, capturing everything from debug info to critical errors. But with massive, scattered logs, searching can be overwhelming. Google's cloud logging service centralizes all your logs, making them easy to manage. If you use a Google-managed database, just enable logging. For custom solutions, install and configure the Ops agent. Once set up, your logs flow into cloud logging automatically. To view them, log into the Google Web Console and search for Logs Explorer. Logs Explorer displays all your log entries and lets you filter by time, resource type, severity, and more. For example, you can narrow results to Cloud SQL warnings from the last 12 hours. Use the filter options or write your own filter expressions. The search feature highlights keywords like fail or insecure, helping you pinpoint issues fast. Click any entry to expand details, formatted in JSON. Need to analyze logs elsewhere? Use the Create Sync option to export filtered logs to cloud storage, BigQuery, or Splunk. Just name your sync, set filters, and choose your destination. With cloud logging and Logs Explorer, tracking down database issues becomes faster and more manageable. Use filters, search, and export tools to find exactly what you need.
Google Cloud Platform, or GCP, enforces quotas to limit how you use their services. For example, Cloud Firestore allows only 200 composite indexes per database. Knowing these limits is crucial for smooth operations. To check your quotas, log in to the GCP Web Console and search for IAM. Scroll down the left menu to find Quotas. Here, you will see all your quotas, often with multiple limits per product. Use the filter to narrow down to the service you are interested in, like BigQuery. For instance, BigQuery has a quota of 3,000 IAM policy requests per minute. Exceeding this will result in errors. If you need a higher quota, select the relevant entry and click Edit Quotas. Enter your new maximum, provide a compelling justification, and include your contact information. Google will review your request and may approve or deny it, so be clear about your needs. Set up monitoring by clicking the Show Usage Chart icon to compare your usage to the maximum. You can also create quota alerts, which notify you when you approach a limit, and customize notification channels. Always review quotas for your services, set up alerts, and request increases when necessary to avoid disruptions. Thank you, and see you in the next part. If you're not already subscribed, please subscribe to our YouTube channel. Check out our website for the latest real exam question and answers PDFs. Happy learning!